Right, the last section here in chapter 5 is equations and graphs of trig functions. So this is kind of putting it all together and doing some word problems or problem solving with it. So on your graphing calculators, I want you to punch in the following trig functions and then tell me what the period is. So pull out your calculators and put that in there, and then we'll come back to it. Okay, so you have the two graphs here. The red graph is the graph of y is equal to 2 sine 2 pi over 3 times x minus 1 plus 3. And then the blue graph is the graph of y is equal to 5 cos 2 pi over 5 times x minus 4 plus 1. So the question was, what is the period of this graph? So we know that in order for it to have covered a period, we have to go through one complete cycle. So for a sine graph, that means that you have to have crossed the x-axis, or whichever way you want to think about it. This one, of course, because it's shifted up, doesn't cross the x-axis right on 0. But we want to see where it has gone from the start, done a full up, full down, and then back again to the start. So for that to happen in this one, it's at this point here. Whoops, don't know why it switched on me. Let's go back. At 0.25, and this is not in radians in the way we would write that. 0.25 would be pi over 4, because that's a quarter. And I don't know on this particular graphing calculator one if I can change that to this point here. So if I start, do my full swoop, go down, and then back up again, that's going to give me a total of, to this point here, 4.75. So from 0.25 to 4.75, something seems a little off there. And I might have something wrong in my actual calculator. But the one way to do that is to do your counts and then calculate it. If I look at the cos graph, see if that'll bring it up here for you. Oh, I think I have to touch it. Oh, did it again. Sorry. Don't know why it does that. Okay, so on the cos graph, we know that cos starts at the top and then goes down, and then when it gets back up to the top again, that is a full cycle. So it kind of does that funny looking U. So for the cos graph, it's going from here, that's annoying, from here to where it goes back down, back up again, is to here. So that is going from -1 to 4, so it should work out to be a cycle of 5. I'm still trying to figure out why my sine one didn't give me my value that it should have. But so you can see by counting on there, you could calculate it. The other way that we've been doing it is what you're used to in your notes. So we know that period is equal to 2 pi over b. Over b. Our b value for this one is 2 pi over 3. So if I finish my calculation here, this is 2 pi times 3 over 2 pi. So my b would be a 3. For the cos graph, 2 pi over 5, so period is equal to 2 pi over 5, which means this is 2 pi times 5 over 2 pi. So that means your period is a 5. So the first one should have given me a period of 3, and the second one, the cos graph, gives me a period of 5. What you might have noticed is basically, because this had that 2 pi on top of it, and this had the 2 pi on top of it, that my b value was just what was in the denominator there. So it's just a little trick for you to remember. So it says, in order to obtain a period given, use y is equal to sine 2 pi over p, and y is equal to cos 2 pi over p. So if we know the period, then we can find our value. Sorry, b is equal to 3. That should be period is equal to 3. So that's all we were doing. They're calling this the p. What we called it was the b value. Same thing. And I think that's the way it might refer to it in your textbook. So it says some convenient methods for creating functions to match an application. If you have a cosine graph that starts at a maximum, so if it tells you there's a maximum, a graph has a maximum amount, or a function has a maximum value, for a maximum graph, then that means you're going to start here, go down, and go back up. So that's if you're looking at a cos being a positive x, or positive cos x. If it says it's starting at a minimum, then that means for a cos graph, you're going to be down here, going up, and then back down. So that's when we have a negative. Okay, if it says that it's starting at the center and rising, then that means we have a sine graph. So it's going to start here, and then rise, and then continue. So it's just basically a regular sine graph. If it says it starts at center and it's falling, then you're going to have that negative sine graph. So these are just some key words or key phrases for you to keep in your memory bank for when you're doing these questions. So let's apply this. It says a Ferris wheel has a radius of 42 meters. Its center is 43 meters above the ground. It rotates once every 50 seconds. Suppose you get on at the bottom and your time is equal to 0. So it says graph how your height above the ground varies during the first 2 cycles. So this one, if you think about it, when you're starting, you're at the bottom, and then you're going up. So you have to think of what kind of a graph will that be. That's going to look more like a sine graph. And then, sorry, it's going to look at a sine graph because you're starting at the 0, and then you're going up, and then back down again. So the first thing you want to do is you want to draw this, and you have to think about, okay, what does it look like on a Ferris wheel? So if you were just to draw a simple looking Ferris wheel, where's my shapes? So I'm just going to draw a circle. Whoops, I don't want to, maybe that big. So on my circle here, starting at the middle, it says that it has a radius of 42 meters. Its center is 43 meters above the ground. So that means this distance from here to here, if this is my ground, is 43 meters. So that's what the basics of this would look like. It told me that every 50 seconds it will go all the way around, so it'll do that 2 pi or 360 degrees within 50 seconds. So if we want to figure out what this would look like if we graph this as a function, you have to think about, okay, pick a couple of points on there where you know what the height is going to be, and you would know what the time would be. So the first thing we do is just draw a really basic diagram of what we have. The second thing we want to do is pick 2 to 3 points. Well, actually, probably more than that. We'll pick a few points, but 3 would be your minimum that you want to do. When we're working with our graphs, if you remember, we're always dividing them into those 4 key points. So that's really what you want to do, is at those 4 key points. With your start, we know our start's going to be at 0. So if I think about this, if I do a quarter of a turn, and I'll do that in red. So quarter of a turn if I go from here to here. So that's a quarter of the way, would be there. My time that it would have taken me, if it's 50 seconds all the way around, so 25 would be half, so 12.5 seconds is what it would take to do that. Your height at that point would be, if I drew a line straight across here, because that would be perfectly in half there, my height would be this 42 plus my 1 meter off the ground. So I'd have a 43 meter height. Whoops. If I were to do this at a half a turn, so half a turn if I'm starting here and I'm going to here, what would my height be? Well, I would have my 43 meters to here, and then this height, the radius of 42. So at a half turn, which would take me 25 seconds to get there, I would have my 43 feet that I was to the center, and then 42 feet to the top there, so it'd be 85 meters. If I did 3/4 of a turn, I guess I'll do that in green, so 3/4 would get me to there. That means I would have gone my 25 seconds to the half and another 12.5 seconds, so that's going to be 37.5 seconds. My height there again is going to be this distance to here, so that's 43 meters. And then when I make my full turn, oh, well, this isn't going to, let me pick another color, I'll do orange. My full turn then, go from here all the way back around. That's going to take me 50 seconds. And my height there then is going to be at right where I started, which is 1 meter off the ground, so I'm ending here, so my height is 1 meter. And then, of course, before I even started, I would be at 0 seconds and 1 meter. So that one I actually could have put right at the beginning here, but it doesn't really matter. So then what we want to do is we want to plot this. So my time is going across the bottom. This is time in seconds. And my height in meters is going up my y. And I always want to label what I've got going on there. So I'm going, my height, I could do this just in 10 meters. So this would be 10, 20, 30, 40, 50, 60, 70, 80, and then 90. And my time, because this asked me to do it in 2 full cycles, so I need 100 seconds on there. So let's see, if this should get me to 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 would be right there. So 10, 20, 30, 40, 50, 60. And I'd end up at 100 there. Okay, so then I plot this. So starting at 0, I am 1 meter above. So this is going to be approximate, of course. So about there. Quarter turn is 12.5 seconds, and I'm at 43 meters. Half a turn is 25 seconds, and I'm at 85 meters. 3/4 of a turn, that's 37.5. So it's going to be a little bit, and 43 meters again, so about there. When I do a full turn at 50 seconds, I'm back down to 1 meter. And then when I do my second rotation then, I'm going to be The next one will be 12.5, so that's going to be at 62.5, and back up to my 43. Then from 62, I'll just write these times down here. So 62.5, another 12.5 will be 12.5. Yeah, will be 75 seconds. So at 7 seconds, I'm back up here at 85 meters. Then at 87.5, I'm back down at my 43. That's pretty close. And then at 100, then I'm right back where I started from, which is the 0. So my graph, if I plot this, is going to look like, oops, like that. Okay, so now part B here asks you to write an equation that expresses your height as a function of the elapsed time. So what they're saying is, write an equation for this graph. If you think about this, this graph reached a height of 42, right? If it started at 1 and went to 43, so then the total height was 42. So that means that your amplitude for this one is a 42. The period for this one then will be at, it completed a whole cycle, so it did 2 pi in 50 seconds. So that reduces to a pi over 25. So that is going to be our B value, will be that pi over 25. If we look at then our that K value, the K value is always your maximum plus your minimum, and then divide by 2. So if my maximum was a 43, plus my minimum, which was 1, and I divide that by 2, that gives me 44 divided by 2, so it's a 22. So if you think about that on the graph here, if we look at where our center line would be, it would be going up. Sorry, I lied, because our maximum was an 85. This should be an 85 plus 1. I gave you my minimum, or that value instead. 85 plus 1 divided by 2 is going to give me my K, so that's 86 divided by 2, so it's a 43. 43 would be where that graph was cut perfectly in half. So that means that that is your K value. So your equation, if we looked at our graph, because of the way it starts down and then goes up, that's just the opposite of a regular cos graph. So it would be a negative cos of 42. Sorry, 42 should go first. Negative 42 cos of pi over 25 x, and then that plus 43. So you could change this into a function in terms of height and time by just doing h of t is equal to negative 42 cos, pi over 25x plus 43. Okay, C says estimate your height above the ground after 65 seconds. So you can do this in your graphing calculators. And I'm going to give you the steps to do it on the trig ones, and then I'll show you on our regular one. But on the Texas Instrument ones, you do just clear just to make sure everything's good. And then you use the vars button. Oops. I'm trying to find that. Oh, it's right beside the clear. So you do clear vars, and then we want the y vars, it's called. So we have to move over to the y vars. I think that just stands for variable. So vars or y vars, and then we want function, which is what it's on. And then once you hit function, it has y1 is your first choice. So you do y1. Whoops, that's a y. y1. And then where it says y1, you put in a 65. Whoops. Okay, 65, and then enter. And that will give you a value. And that value is at about 55.9. Okay, so after 65 seconds, your height will be 55.9 meters. So that's doing it on your graphing calculator. On the graph itself, if you want to do 65, and of course, because this is a little bit off because of my graph isn't perfect, but if you were to draw a line straight up here, where you can see it's almost at 60. On my calculator that I did it on here, oh, I don't have the equation plugged in here. Okay, I'm just going to pause and I'll put the equation in there. Okay, so here's the graph of that, and if I want to get it at 65, at 65 seconds, and this probably is going to switch off on me, so I'll have to come back to it, but basically, yeah. Try again. So if I take my, and I go till I hit 65, well, you can see that it flashed on there very quickly that it was at, oh, I don't know why it's doing that. That is so annoying. So at 65 here, whoops. Anyway, I'm not wasting any more time doing that. At 65, when I had it on there, it said that 55.98 something something. Okay, so there's 3 different ways of doing it. The last way to do it would be, of course, to substitute 65 in here, whoops, into that HT, and then go backwards and solve. Okay, so then the next part says estimate one of the times when your height is 25 meters above the ground. So this one wants us to do it algebraically. So that's when we actually would substitute in here. We would say 25 is equal to negative 42 cos pi over 25x is 43. So first thing we would do is subtract that 43, and we would have negative 18 equals negative 42 cos pi over 25x. Divide by negative 42. So this is 3 over 7 equals cos pi over 25x. And really that x should have been a t right here also. That should have been a t because we're using height and times instead of x and y, but same difference. Okay, so to get now our pi over 25x by itself, we need to get rid of this cos. So that means we have to do the inverse cos. So cos negative 1 of 3 over 7 is equal to pi over 25 times x. So now I want x all by itself. And you can do this all in one step, or you can do it in 2 steps. But if I want to get rid of this pi over 25, that means I'm going to divide by 25 over pi on both sides. So I would have 25 cos of negative 1, or cos inverse of 3 over 7 all over pi, and that equals x. So when you put that into your calculator, you get 8.98 seconds is equal to x, or t, if you're working with time. So it can be solved by working your equation. It just takes a few more steps, and if you can do it on your calculator, then when it comes time to doing your exam, it'll just be that much quicker. Okay, B. So next example says, at a seaport, the water has a maximum depth of 15 meters at 7 a.m. and the minimum depth of 5 meters occurs at 1:30. Assume the relation between the depth of water and the time is a sinusoidal function. So we want to write an equation for the depth in meters, which is meters, or in h meters, of the water at any time, which is t hours. Okay. So what we need to think about first is, if we know this is a sinusoidal function, so it's going to go like that. So you got to think about what information are they giving you. We know our maximum occurs at 15 meters. So if we were to do this on a graph, this point here would be at 15 meters. The minimum depth of 5 meters occurs at 1:30 p.m. So this down here, minimum depth would be here, which is at, oops, I should put this, because this would be going along, your height's going to go along the y-axis. So 15 and 5. And that 5 meters there occurs at, this is at 7 a.m. And if we think of a 24-hour clock, 1:30 is the same as 13:30 hours, or 13 and a half hours. So 13 and a half hours that way. So with this information that they've given us right now, we can figure out a few of the variables that we need to get our equation, just with the basics that we have. So if we have a maximum at 15 meters, we can find our amplitude. Our minimum occurred at 5 meters. Divide that by 2, that's going to be a 5. So 15 minus 5 is 10, divided by 2 is 5. Our period then to go from the part that we're talking here that they've told us, so this is actually from 7 a.m. to 1:30 is 6.5 hours. So if it's 6.5 hours there, then we know to do the whole period is going to be 13 hours. Okay, so it's at 6.5 times 2. Our center line, or that displacement, is going to be at, which is, we call that the k value, is when we do the maximum plus the minimum and divide it by 2, so that's at 10. So we know that that's where our vertical displacement is going to take place. And our phase shift, where we are starting, where they're saying here from the maximum at 7 a.m. to the minimum at 1:30, means that the phase shift here, this is where we're going to start, is on this side of it. So that's a 7 hour where it started instead of at 0. So our phase shift then, oops, put that in the wrong spot, is a 7. So based on this information, we can figure out where we're going to go with our function. So if we're saying our phase shift is starting here, what kind of a function is that? Well, when we start up, we know that that up value means that we have a cos function. So knowing we have a cos function, we're writing this distance is a function of time, where we have our a value was 5, our amplitude was 5, cos our phase shift, not our phase shift, our period was equal to 6.5. Sorry, it was equal to 13. So that means 13 is equal to 2 pi over b. So b is equal to 2 pi over 13. So that means we have 5 cos of 2 pi over 13 times, and instead of an x, because we're using our time and the depth and the time, so it's going to be t, and our phase shift was 7 to the right, so minus 7. And then our vertical displacement was up 10. So this would be our vertical displacement right here, would be at 10. So that's what your graph would look like, and then the function that would describe that graph. So dt is equal to 5 cos 2 pi over 3 times t minus 7 plus 10. So it says estimate the depth at 11 a.m. So at 11 a.m., if you substitute just into this formula, put it into your calculator, and just solve. So if your t is equal to, if we're thinking 2400 hour clock, so your t is equal to 11. When you substitute that in there, the time would be, the depth would be 8.23 meters. So what they're saying there is at 11 o'clock. So if this is at 7, at 11, which would be about here. So we're about right there, that would be about 8.23 meters. C part says a cargo ship's hull floats at a depth of 8 meters. How long can it be in the port to load its cargo? Using a graphing calculator and the zero intercept method. So what we want to know then is, when is the height at least 8 meters? So when is it between, let me pick a different color here. How about, I'll do red. So we want to know for C, when is it in between, if this is 8 and up? Throughout what time? So we're looking at this period in here. Because as soon as it'll start at 8 meters, rise up to 15, and then start going back down till it hits 8 and then goes lower and lower and lower. So that's what we want to know. We want to know when is the depth, or the d, equal to 8. So what are the spots on the graph? Where depth is equal to 8. So what you want to do on your graphing calculators, and I'm just going to give you the steps for it because I don't have the Texas Instrument one for the smartboard. So on your graphing calculator, what you do is you enter in the equation. So you do y1 is equal to 5 cos bracket 2 pi over 13, excuse me, put in another bracket, t minus 7, then close off your bracket. So you should have a double bracket there, plus 10. Then what we want to do is let y2 equal 8. Because what's going to happen then is it's going to draw exactly this. It's going to draw my blue graph here, and then it's going to have that graph, my red graph, where it has cut, going straight through there. Okay, so then what we do is on your button, or on your calculator, I'm just going to pause and enter it into mine here. Okay, so on your calculator, you want to do, once you've got these two graphed in here, you might need to, and I'm not sure if it is absolutely necessary, but you might have to put that 2 pi over 13 in a bracket so it doesn't go 2 pi divided by 13 over t minus 7. Just a good idea. So what you're going to do is you're going to do second and then calc, which is the trace button. We want to do the intersect, intersect, which is 5. And then when it comes up, you're going to have your thing going like this. If you're looking for windows to set, just look at what values we're looking at. So on our x, we've gone from 0 to, well, 13 and a half, so you could say 0 to 15. And on our y, we've gone from 0 to 15 is the maximum, so you could go a couple above and say 17. So then on the window that you get, you should have a graph that looks something like this. So once you've done second calc intersect 5, your cursor is going to be flashing. So you want the cursor to move the cursor so that it's below, flashing there, and then you hit. So you might need to move your cursor. Hit enter, and it'll say Y2. And Y2 it should, or second curve it'll say, so your cursor then should be flashing somewhere on this Y is equal to 8 line. So you hit enter again. And then it says guess. So this is second curve. And then it says guess. And you hit enter. And it should give you the values at the bottom. X is equal to 2.89. 5 something. 2.8985. Just going to pause once. So it'll say y is equal to 2.8985, so 2.899 is good, and y is equal to 8. So that gives you this spot here. We also want this spot, because that means that the time in between here is where we'll be at, where it'll be safe for it to be in port. So you're going to do the exact same steps, except you're going to have to move your cursor over when you do it the second time. So you do your second calc 5. Your cursor is going to be flashing wherever it is. You need to make sure you just go move it way over to the other side. Excuse me for bump here. So your cursor will probably be flashing somewhere in this area here. You have to just keep hitting that right arrow button and move it so that it's just above the line somewhere in here. So once you've done that, you can hit enter, and it should be close. It doesn't have to be right on it. Hit enter, so you got first curve, enter, it says second curve should be flashing on that y is equal to 8. Hit enter, guess, and it should tell you 11.101 something. So your second one then is at x is equal to 11.0 or 11.10. So that means the first time it happens is at about 2 o'clock in the morning, so 2.89, so almost at 3 o'clock. And then again at 11.1 hours, so that's just past 11 o'clock in the morning. So what you can do then is we need to, because the question said, how long will it be in port? That's when you'd say, that's when you do just a little bit of basic math calculation there. 11.1 minus 2.9 is equal to 8.2 hours. So it can be in port for about just over 8 hours. Okay. Next question. Daylight by day of the year for Windsor, Ontario. So They had, on day 21, they had 9.62 hours. On day 52, they had 10.87 hours, and then so on. So basically, this would be January 21st. This is another, will be into March, I guess, 50 days into that. Would it be? Or just, I guess, end of February-ish in there. And then so on. So it says, write a sinusoidal function for the data. So we know these are our days, the number of days, and these are the number of hours that they've given us. And now they want us to calculate a sinusoidal function for this. So if you go through our values here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Makes sense for the 12 months of the year. So our middle value, or our maximum value, I mean, if we take a look at all of these, is this 15.28. So this is our maximum value. The least amount of daylight occurred here at 9.08 hours. So if we want to find our amplitude, we take a look at the maximum and minimum. So our amplitude, so my maximum minus my minimum divided by 2 means that I have 15.28 minus 9.08, and I divide that by 2. So there's a difference there of 6.2, so that leaves me with 3.1 as my amplitude. My center line, or that vertical disposition, is maximum plus minimum divided by 2, so 15.28 plus 9.08 divided by 2 is 12.18. My period then, this whole cycle, if you added up all the days, is 365 days. Our phase shift then, we want to start at the maximum value. That's where our phase shift, drawing this graph. So it's 172 to the right. So 172 to the right. So if our period is equal to 365 days, then that means our B value is going to be 2 pi over 365. So we can make our function here, y is equal to, so if I think about this, whoops, I'm going to have to move this over here if I draw my diagram. If I'm doing my maximum value here at 15.28, and then it starts to go down, 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 and this is my phase shift going from there, then I know that I have a cos graph happening here. Because I'm not starting at 0 anywhere. It never hits 0 hours, so then that's why I know I have to do the maximum, start at the maximum, which means with that phase shift in the middle there that I'm going to be doing a cos graph. Okay, so if I substitute everything I know, y is equal to 3.1 cos of 2 pi over 365 times, excuse me, x minus my phase shift of 172, close that bracket, and then my center line was plus 12.18. So on March 10th then is the second part of this, says estimate the number of hours of daylight on March 10th. So what I need to do then is, that's going to give me my X value, right? So March 10th means that I am, this is January, so I had 21 days in January, plus 52 days in February. Sorry, not 52 days. That's my days of the month. I had it right, but I wrote down the wrong number. So January is 31 days. February is 28. Then plus 10 days. 69 days that we're into this. So that means then what you're going to do is you're going to substitute in a 69 into this function. So y is equal to, and you can do this just right in your calculator. If you go 3.1, you don't have to do the y equals, but 3.1 cos 2 pi over 365. And again, you'll probably have to put that in its own bracket. 69 minus 172, close your bracket, plus 12.18. And when you do that, your y should equal 11.6 hours. Okay, I'm not going to bother with the last problem on here. If you want to try it, and if you have questions, you can ask me, but it's just basically a repeat of what we've done. So that's it for this unit. You'll be doing these questions and then the review, and your exam will follow.